Okay, let's look at this one first. There's nothing to do on this sheet. Okay, it's already given to you. There are examples here, starting with the most basic forms. So 1 carbon, methane. Okay, this is what it would look like in its structural form. This is what its molecular form would be. Then we go to ethane with 2 carbons. Again, its molecular form, its structural form, and then its condensed forms. Okay, next we get to propane, 3 carbons. Molecular formula, structural formula, and then its condensed forms. This one here, as in the notes, just shows the bonds between the carbons and then no lines in its condensed form. Now, once we get to 4 and 5 here, okay, these are both C4H10. However, they are isomers. Okay, in the first case, butane, we have our 4 carbons in a row. But in 5, I only have 3 carbons, and then I have 1 branch. So it's 2-methylpropane with that 1 methyl branch being on the 2nd carbon. Okay, so there's nothing to do on this. It's just showing you the different examples. Now on the second page, six, 7, and 8, all have 5 carbons. Okay, but they don't all have the same form. They're all isomers. The first one with 1, 2, 3, 4, 5 carbons in a row, well, that is pentane. 7 has 4 carbons, so it would be a butane, but it has 1 branch. So there's a methyl branch. So this would be a 2-methyl butane. Again, 4 carbons, that's the butane, 1 branch, that's the methyl, and it's on the 2nd carbon. Now, please note, I call it 2nd carbon because if I start on this side, that would be the 2nd carbon. Now, if you say, well, what if I put it over here? Would that make it the 3rd carbon? No, because starting on that side, that would be the 2nd carbon again. So flipping it around, basically, there is no 3-methylbutane because that would be right back to 2-methyl, just flipping it around. So it's my same hand this way or this way. Doesn't change anything. 8, now I have 2 branches, but I only have a chain of 3 carbons. I can go this way for 3 carbons, or I can go this way for 3 carbons, but it's still a maximum of 3 carbons. So this one is a propane, but with those 2 branches, then I'm going to have a 2,2-dimethyl propane. So 6, 7, and 8 all have 5 carbons, but they're arranged in 3 different ways. Pentane, 5 in a row. Butane, 4 in a row with 1 methyl branch. And then the last one, propane, 3 in a row with 2 branches, 2 methyl branches. And then notice that each one's labeled. So it's 2,2-dimethylpropane or 2-methylbutane to label the branch. Now 9 through 13 are all isomers. They're all C6H14. But again, just to show how the name changes depending on the length of the chain and then what branches we have. So 1, 2, 3, 4, 5, 6. We're back to our hexane. This is a partially condensed form. This is a totally condensed, no lines. And then here, 1 branch on the 2nd carbon. So it's a 2-methyl pentane. Again, pentane because there's only 5 carbons in the main chain. Whereas the next one would be a 3-methyl pentane because the branch is on the 3rd carbon instead of the 2nd carbon. So 2-methyl, 3-methyl. 5 for pentane, 5 again here for pentane. Now you might say, hey, can I go to the next one and have 4-methyl? No, because if I went to this carbon, that would actually be the same as 10, just flipped. Because from this side, that would be back to carbon 2. So there are only 2 possibilities here. I can have 2-methyl or 3-methyl. Can't go to 4 because 4 is back to what would be 2 from the other direction. And then in 12 and 13, I have 2 branches now. Okay, the first one would be 2,3-dimethyl, and then butane, because the main chain is now only 4 carbons. And then the last one, it would be 2,2-dimethyl butane, because they're both on the same carbon. And again, I can't have a 3,3 because if I put them both on this carbon, that would be number 2 again, but they would be number 2 from that side instead of number 2 from this side. So there's always that symmetry. It can be 1, 2, 3, 4 going this way, but if I put both these carbons over here, then it would have been 1, 2, 3, 4 from that side. So there's not another form. There's only going to be just the 1, 2, 3, 4. So 2, 3 on 2 different carbons, or 2, 2 on the same carbon. But 9, 10, 11, 12, 13, all isomers because they're all C6H14. But notice how a different form has a different name. Yes? So this is not homework. This was just to show you how the names change for the variety of forms. Any questions on this sheet?